skin of the wing is attached to the frame with thousands of fasteners. Every one of them is vital. Mistakes here could cost lives. So each and every fastener is double checked.
We're fastening up the panel to the spars and torquing it with this nut setter. And then once we're done fastening it, we go through again to make sure it's all torqued down.
As the wing nears completion, it starts to take on its unique shape. It's the shape of the wing that will lift a 440,000 kilo jumbo into the air. As wings move through the air, they create an area of low pressure above and high pressure below, which creates lift.
Whenever the airplane is in flight, of course there's air flowing around the wing, and the net pressure, if you will, on the wing is one in an upward direction.
There's just one problem. When these airflows meet at the wing tips, air from below the wing moves around to the top. Circular flow forms a vortex, or dirty air. This dirty air adds downward pressure on the wing and reduces the lift it can generate. The solution is slanted or raked wing tips. These new wing tips force the vortices to form at the very end of the wings and help reduce drag. The new design also creates new challenges. Test flights reveal a small vibration in the wings known as flutter. The wings have been oscillating up to 5 centimeters.
During the testing on the airplane, we put the airplane through all corners of the envelope, the speed envelope, the altitude envelope. When we were at high speed with certain payload on the airplane and certain fuel, we did notice a small vibration of the wing and engine combination.
In extreme cases, flutter could bring a plane down by literally shaking the wings off. To meet regulations and prevent delays, the problem with the wing needs to be eliminated, or it could ground the 747 program. And not for the first time. In the late 60s, the original 747 had a different wing issue. Wind tunnel tests showed the pressure on the wing was not distributed correctly, threatening a complete redesign. But Joe Sutter came to the rescue.
We came up with the idea of just twisting the outward wing down a couple of degrees. The thought was maybe this would work. Well, they tried that in the wind tunnel, and with just that simple fix, we solved the problem.
This simple fix works. It distributes the stresses on the jumbo's wings correctly, and the 747 is good to go. In Joe's honor, it's dubbed the Sutter Twist. The twist is key to the Incredibles completing the jumbo on time for its launch. But the Dash 8 story takes a different twist. In a typically 21st century solution, engineers use the plane's computer systems to cancel out the vibrations. They call this computerized system fly-by-wire, a huge improvement on the cables that used to control the wings.
A pilot input would cause a cable to move, which would in turn signal to the surface to move. A fly-by-wire system is where you've got computers in the loop. It's where a pilot will move the column, turn the wheel, and when they do that, it sends an electronic signal by a wire to the actuator that will control the surface. Now, what that allows you to do is put more computer and more flight control software technology into the handling characteristics of the airplane.
They can use the computer system to make tiny changes to the wing controls to cancel out the flutter. It's a simple solution in the spirit of Joe Sutter's Incredibles.
I have an immense amount of pride working on a product that Joe Sutter and his team effectively designed, built, and tested before I was in kindergarten.
In 1968, Joe Sutter and his team of Incredibles give the world the most iconic shape in commercial aviation history. that famous hump. But they don't design it as a first-class retreat for the jet set. Because Boeing thinks the future is supersonic, they see the Jumbo's future as a freighter.
So, luckily, the passenger requirement for 350 passengers and the big freight capacity requirements blended together, so we could build a fairly optimum airplane for both the passenger role and the freight role.
Getting passengers on is easy. Getting large cargo on, that's a challenge.
We looked at a lot of different schemes, and one concept was to put a nose door on the airplane, or some way of loading freight from the nose.
In a radical design move, cargo will enter through the nose. This places the flight deck above and out of the way. And so that famous hump is born. Pan Am President Juan Trippe immediately sees the potential.
Juan Trippe turned around and looked at this area and says, "What's this used for?" And his chief engineer said, "Well, it'd be a good crew rest area." And Juan Trippe looked at the engineer and says, "This will be reserved for passengers." And that's how this upper deck that we now fly on came into being.
On the new passenger 747, that iconic hump has expanded to the length of an entire 737. Back at the factory, work is progressing on the fuselage. It's built in several sections: rear, middle, and the front, with that famous hump. Each section is assembled panel by panel. All the body panels are coated with a green protective vinyl to prevent damage during construction. Only the nose is made as one piece. The lower part of the main body is built upside down for easier workflow. Then it's rotated 180 degrees in a special turn fixture so they can put on the roof. Once assembled, it's so unwieldy, only a mammoth 34-ton crane can lift it. A total of 26 cranes on 50 kilometers of ceiling tracks fly the sections around the massive complex.
You're gonna tell all the airline pilots that, hey, we flew them first for you. We can just pick it up and fly it wherever it's got to go. Set it back down, and people get to go to work on it. There are a couple people that have a fear of heights that are in this job, but it's best if you don't.
Before the fuselage pieces are moved to their final assembly position, it's critical to make sure that nothing is left behind. A loose bolt could cause a disaster if it rolled into the wrong place, such as an engine or even one of the fuel tanks.
Every rivet, every fastener you put in, it could be a critical item. I remember an old saying I heard years ago: quantity is something you count, quality is something you count on.
It's 2 a.m., but Boeing never sleeps. Inside the world's largest building, an extremely complicated maneuver is underway. So far, the Dash 8 team has built her wings and her fuselage. Now it's time to bring it all together. To make this Dash 8 look like a jumbo. Joining up the three sections of the fuselage is one of the most demanding jobs in the entire assembly process, which is why it's done in the dead of night. It's safer, fewer people on the floor, less chance of something going wrong. With millions of dollars worth of aircraft parts coming together, this is an extremely delicate industrial dance. The ground crew have to pay attention to the smallest details. The crew are positioning the forward section to receive the wings. When lowering a section, the team must be precise.
Line up, make sure that we set in the cradle at the right position. It's a matter
wings are now joined to the centre fuselage. They span almost the entire width of the factory floor. Two tractors must pull at exactly the same speed to stop the wing section from veering off into the sides of the factory. The clearance between the walls and the wing tips is just 5 centimetres. Next, the tail section joins up with the rest of the plane. The characteristic jumbo outline is taking shape. She's 76 metres long and 68 metres across. Thousands of hands have got the aircraft to this stage. The task of managing and organising such a large crew isn't easy. But it's something Boeing has had plenty of practice at over the last 40 years. During the early years, Boeing faced a financial meltdown. It came close to bankruptcy. There were layoffs and pressure to halt development. Running the 747 program was a real challenge.
We were working very hard to get all of the drawings out at that time, so the engineering department was peaking out at about 4,500 people. I was asked to make a big cut in that. We needed 800 more engineers. I think maybe I'm going to lose my job today, but I'm going to tell them the way I see it. I figured that was when I did the best job I could have for Boeing. If I had reduced the engineering force, the whole program could have tumbled.
The latest jumbo jet program also has the potential to tumble. In 2008, Boeing's machinists go on strike for 2 months, throwing an already tight schedule into disarray. Each day lost costs Boeing $100 million. Added to the wing engineering issues, Boeing is forced to delay delivery by 2 years. Some buyers cancel their orders. But Boeing's immediate concern is to finish this one. It's time to give her some power. Time for the new engines. 4 revolutionary ones. The old 747 engines consume over 12,000 litres of fuel per hour. With oil prices at an all-time high, airlines are seeking any way to minimise fuel consumption. Finding a more efficient engine is critical to the Dash 8's success. General Electric is at the forefront of jet engine design. These brand new engines are the most efficient they have ever made. Boeing challenged GE to adapt them for the new 747. But they don't come cheap. With a list price of $20 million each, these engines are the new jumbo's single most expensive component. But they are worth every cent. Composite materials used in the fan blades and casing trim 180 kilograms from each engine. Multiply that by 4, and it equals almost 10 extra passengers. And with fewer fan blades and lower turning speeds, these are the quietest engines GE has ever made. They can push through more air with less work. And that means burning less fuel. So how do they do that? Only 10% of the air is mixed with fuel and burnt in the combustion chamber, driving a series of turbines that power the big fan at the front. And that's the fan which pushes the other 90% of the air out the back of the engine, creating thrust. Despite burning less fuel, 4 of them can propel a fully laden 747-8 at over 1,000 kilometers per hour. Just one of these engines creates as much thrust as all 8 engines on a B-52. Back at the factory, it's time to hang the engines. Massive concrete blocks hang on the wings, where the engines will go. Without them, the aeroplane would tip back on its tail. Each engine weighs 7 tons, and there are 4 engines to get off their trolleys and onto the wings. That's like hanging 4 bull elephants. It's a job to do slowly and carefully.
Let me put a little tension on it and test it.
If the 4 winches are slightly misaligned, it won't go in square, and they're in trouble.
45. Got your wheels where you want them?
Our team's a pretty tight unit. We work together fairly well. We all have our positions on the plane that we like.
0.
All right, start pulling your pins. We communicate well together this way. Keeps us from getting into any troubles. Harness up for safety. We're about 12 inches away. We're going to pull the bolts from the front fitting. There's a pin up front that lines up the forward mount. So we lube that up with anti-seize. We'll come up another 6 inches, make sure everything is clear. Then we'll come up the last 6 inches and then put all 4 bolts in. Very close tolerance, within a thousandth of an inch. Come on up. Okay.
It only takes 8 bolts to hang these massive engines.
All 4 started. All grabbing.
Here you go, 50%?
Not yet. I'm still getting these down, Axel.
Okay. The torque on those bolts are 625 foot-pounds on the rear, 375 foot-pounds on the front. The fronts are designed to shear off. That's per design, and that's in case there is any problems that the engine will shear at the front, fall back, and break away from the plane without taking out wings or flaps or any of that. There's one.
There are 3 more engines to mount. Once again, the crew will need to burn the midnight oil to get the job done. After weeks of painstaking work, it's almost time to switch the beast on. But first, there's more painstaking work. Every circuit needs to be checked, one by one. This plane uses a lot of electricity, enough to power over 50 households. 214 kilometers of wiring runs through the aircraft. It all converges in the electronics bay. It's the plane's nervous system. The new fly-by-wire technology is controlled by onboard computers. But it's not totally automated. The pilot can override the computer. And there are multiple layers of backup if something should go wrong.
If I were to lower the flaps, it takes hydraulic systems to do that. But if for some reason the hydraulics were unavailable, we could use the air or pneumatic air pressure to lower the flaps. If that was unavailable, we could use electricity to lower the flaps. So there's multiple layers of redundancy.
Technicians use a special computer to send a test signal to every single circuit.
Ticket breaker 10495. On.
Okay, Kilo 2.
Bravo 24 and Bravo 21. Off.
The moment of truth. Time to plug in the factory power supply and fire her up for the first time. Power on is a key moment in completing a Dash 8. With engines in place, this jumbo is almost ready to take to the skies. But first, she needs an interior. Like the GENX engines and wings, her new interior is borrowed from her little sister, the Dreamliner. There's new colours, more space, and mood lighting. Boeing customers have their own idea of interior design. Each wants their jumbo painted in their colours, inside and out. In the Mega Factory's huge paint shop, the green protective vinyl is washed off. A base layer is sprayed on by hand, followed by several coats of colour, depending on the customer's livery. They need to be careful with the number of layers they apply. Too much paint could mask telltale signs of metal fatigue. And besides, the extra weight of more paint would only increase fuel consumption. A typical paint job uses 500 kilos of paint. It will last 4 years. This one is painted in Boeing's own colours because it's time to put her through her paces. She must undergo a series of grueling test flights before delivery. Test pilots push the plane to extremes that will never be endured by its passengers, unless they work for Boeing. Just putting away the hand luggage won't be enough for this flight. These Boeing engineers have to tie everything down, from their lunch to their laptop.
You don't have it clamp down, things fly in the air, and it'll literally go straight up to the ceiling, and it can come down and hit you on the head.
The flight load survey is one of the most grueling tests for the plane, and for those on board. A strong stomach comes in handy. It might look like fun, but it's serious business. The flight load survey tests weight loads across the plane. The pilots perform extreme maneuvers, pitching the plane up, then down, going from 0 gravity to 2 Gs in seconds, stressing the fuselage and the wings.
It's great fun for them for the first couple of minutes, but imagine that we do this for several hours at a time. Sooner or later, maybe it's not such great fun anymore.
During these tests, the weight distribution of the plane is controlled using water. The pilots and engineers can pump water through barrels to shift weight along the fuselage. This simulates various load configurations the plane might encounter when it's in service.
At the forward center of gravity, aft center of gravity, heavyweight, lightweight, we need to make sure that over the entire range of operating envelope of the airplane that the characteristics are good.
Next, the Dash 8 faces the grueling velocity minimum unstick test. Test pilots try to take off as slowly as possible. This forces the tail to scrape the runway. To pass the test, the plane must safely lift off at this speed.
If a pilot were to inadvertently abuse the takeoff and the tail were to strike the ground before takeoff, that the airplane can still lift off safely in that attitude. And so when we do that, we attach a long wooden block on the tail so that we'll drag the tail on the ground and we don't damage the skin of the airplane that way.
Next, they put this new jet through the flutter test. Flutter is the aviation word for vibration. This test pushes fly-by-wire control to the limit.
It's all high speed, generally above the ordinary envelope that we let airline pilots operate the aircraft at. We vibrate each of the axes of the airplane by quite literally kicking the controls one at a time to watch how the controls react and make sure that the airplane in fact damps the vibration out to a quiet and smooth ending in a very quick fashion.
Now it's time to slam on the brakes in mid-air and see what happens.
Airline pilots typically are trained how to recover from an approach to a stall, but rarely, if ever, actually see an aircraft in a stalled state. We see it all the time. We've done hundreds and hundreds of stalls on just this model of airplane, and they're really quite benign.
A stall is when a plane's nose rises too high. The wings then stop generating lift, and the plane begins to fall from the sky.
I just release back pressure on the column and let it migrate towards the center, and sometimes I just drop my hands to my sides. The airplane recovers just fine all by itself.
Thousands of workers have put together 6 million parts to form this one aircraft. She's conquered everything the test pilots could throw at her. She's survived manufacturing delays and deadlines. For just $333 million, you can have a brand new Boeing 747-8 all of your own. The new Jumbo is ready to take on the ultimate test. Competition in the skies.
I would tell new pilots of the 747-8 to be excited. This is a wonderful machine.
And I think this 747-8 will be the airplane that it will be the airplane for the next 20 years.
The world's biggest building, this mega factory, is delivering its 3,381st aircraft. She's a little bit late, but worth the wait. The brand new 747-8 is ready to reclaim her title as Queen of the Skies.